Okay, so let's look at the test real quick. Average was 78.64%. That is the highest average we've had, test 1, test 2, and test 3, if we compare them. Just plugging them in. If we look at test 1, 77% average, you can kind of look at the distribution. A lot more B's. Look at the standard deviation, 13%. Now, these are not normally distributed. So standard deviation is not going to be the same as like the empirical rule, 68% of the data falls within a certain range. But the standard deviation still kind of gives you an idea if the scores are closer together or if they're farther apart. I think this one had the smallest standard deviation. How did this get off? So you can kind of see how that fell there. Exam 2 was a little lower. Standard deviation 14, so a little bit more standard deviation. It's starting to kind of separate the students that kind of know it and the students that don't know it. So the first test, they were closer together. And then the third test has a 14% standard deviation, so standard deviation is increasing. The low scores, bringing that down. Of course, you know, kind of standard deviation, a quick view of standard deviation is kind of how much the points vary. So grading the test was extremely hard on the last couple of problems because most students got all the points or none of the points. And I'm going to go over some of that. And I took that into account. Some of the ones in the beginning was worth, you know, maybe 14 points, 2 points each. But a lot of the range, median, mode, it didn't rely on doing something else correctly. So you could get, you know, -2, -4. But at the end, it was either -8, -10, or +8, +10. There wasn't a lot of, oh, I'm going to take off 3 points for this. So that being said, I curved it 13 points, so 13-point curve. And that was just, you can think of it as like floating bonus. If you got one of the 10-point problems right, it covered another problem maybe that wasn't maybe worth 14 is now worth a little bit more. Overall, pretty consistent to where we've been doing. It's nice to see a lot more A's than B's. The C category though itself is pretty big as well. So let's just go over it real quick. I'll post the answers so you can use them to study for the final exam. The first page, I think there's only 2 or 3 people that missed points on the first page. I don't think anyone missed points on number 1. I don't know why number 1 skipped to number 4, but Microsoft Word does some weird things with me sometimes. But yeah, I don't know.
Totally did not notice that.
Sometimes that happens. I probably put a couple extra spaces for spacing, and it took 3 and
then the
2 and
next
3.
one's 3 and 4.
Yeah, I know. I don't know what happened. It might have been differently, and I just copied and pasted, rearranged them so it kind of fit a little better. But some people missed points on number 4 because they put a bar graph instead of frequency distribution. But again, most people got full credit there, unless they did something crazy. Which again, I don't think anyone. Maybe a couple people missed points on number 3. They didn't put all of them. Some of them didn't put 90 twice. They just had 91. And I don't know if they're like, oh, the zeros aren't important. I'm not going to list that. I don't know what happened there, but pretty straightforward for those points, I think. Number 4 on the second page, students most missed C. Let's see if I can comment here. Categorical data. Some of you guys put like mid-range or median. I think median was one of the most common responses there. Categorical data, there's nowhere to compare if one's higher or lower. So there's no way to put it in order. These are like, give you a survey of what's your favorite pet. The only thing that I can analyze on that is the mode. What comes back the most often. Mid-range is a simple way to compute, looking at average. And then probably another thing that students missed the most on was E. And a lot of you put mode. not affected by one or two extreme values. It would be median, because median's in the middle. So if you have one or two extreme values on the ends, it's not going to affect the median. Mode, it could affect if there was two of them. If it was bimodal, if they had more than one mode, it could change the mode. But other than that, pretty straightforward on that page. Oops, still drawing. Number 5, pretty straightforward on the degrees. Again, a lot of students either got all the points or none of the points on this problem, because if they didn't know the process, they weren't going to get the right answer on any of them. But out of 1,000 just moves the decimal 3 places. So you can just take that as a decimal, take it times 360. If you rounded, perfectly fine. I wasn't too picky on that if you got somewhere close to these numbers. Number 6, probably the thing students missed the most was mid-range. Some of them took 91 minus 65 over 2. That was a common mistake. Median, the mean, median, mode, mid-range, range. Some of you switch range and mid-range. And then a common mistake on the variance was also a lot of you divided by 10 or didn't divide by any number. So you got a really large number there. So it was kind of hard to see. But most got all full points on that page. Number 7 and number 8 are very, very similar. It's just different ways to represent the data. A lot of people got number 8 correct, but not necessarily got number 7 correct, which shows you know the method, but you can't apply it to all the data, all the different ways to organize data. Some of you on number 7 wrote out 56, 67, 68, 71, 72. It was a little easier for you to see, just like it was on number 8. But so median, the first time I just took this real quick, I calculated the mean, and then I didn't pay attention too well. But the median is 76. That's the middle score. The median and Q2 are the same. So I could ask you to find Q2, or I could ask you to find a median, and it's the same process. Mode was 72. The first quartile would be Q1, which is 71.5, between 71 and 72. And if you kind of see on the picture here, I tried to look at that. This is where Q2 would be. This is where Q1 would be, and this is where Q3 would be. And this will be posted on Blackboard. The range, if you wrote 56 and 95, I gave you points for that. If you actually subtract them, you got 39, you got points there too. The 25th percentile, a lot of you calculated N as 4, but then didn't tell me what number had 4 numbers below it, which was 72. So there's some partial credit there. 8, Q1, Q2, Q3, pretty standard if you wrote those from, or an ascending order from smallest to largest. They were pretty straightforward to find. 9, some of the students said 6. A lot of everyone had 60%, which I couldn't really tell where that was coming from, if you just counted wrong or I don't know.
You probably counted.
And some of, yeah, so I was kind of hard to give partial credits, but then again, it was 4 points, so. Yes.
On the quartiles, I'm confused on how that's figured, because I thought that you just write them out in order from smallest to largest, and then you take the 2 that were right above the smallest and right below the largest for 1 and 3, and then you add those 2 numbers and divide them by 2.
So you first thing you do is split the data into 2 parts, and that's Q2. So in this example, there are 9 data points. So the 4th data point will be Q2. This is the 4th data point. It's Q2. It splits the data into.
I thought it was the 5th one.
Was it 5th?
Is in the middle, and there's 2 19s.
Yeah, because
No.
I got that one right.
Oh, there's
but
two 19s. Yeah, sorry, it is the 5th. Sorry. Right, 1, 2, 3, 4. There's 4 data points on this side and 4 data points on this side. Right, so Q2 is 20, because 20 is what splits the data. There's 4 data points on the left and 4 data points on the right. Then you only look at the 4 data points on the left or 4 data points on the left, and you find the middle of those. So here, since there's 4, the middle will be a 2.5.
Well, see, I got that one right, but
And-
on number 7, I
Mhm.
completely, and I don't.
So number 7 is just arranged a little differently. So I put this into a stem and leaf plot so you can, really, I could give it to you as 56, 67, 68, 71, 72, 72,
Right,
so
that's what I
forth.
did.
Yeah, and there were some people that did that, and then Q1 would be in between 71 and 72.
Q1 or Q2?
Q1 would be in between 71 and 72.
Okay. Yeah.
Two-
That's what I'm trying
Yeah.
to figure out how that's, because I took, what was Q2?
Q2 was 76.
And that's,
Well, see, that's what I thought
For Q1,
for Q2.
I didn't ask for Q2.
I know, but
Oh, okay.
I
Okay.
just went through the
Mhm.
process. I found Q2 and
Yeah.
then we went from there.
Mhm.
But like I said, I thought, like, I took 67 and 68 and added it together, divided by 2 to get Q1. And then
Yes.
93 and 94 added together, divided by 2 to get Q3.
93 and 94?
Uh-huh. Yeah, because I took all the numbers from the,
Yeah. Yeah, this is
Yeah.
where
and just wrote them all out.
this is where Q1 would be. Let me see if I can get, Q1 would actually be in between these two.
71, 72.
In between 71 and 72. Q2 would be in between 75 and 77, and Q3 would be in between 85 and 89. Right, because there's four, 1, 2, 3, 4 on the side of this line, and 1, 2, 3, 4 on the side of this line. There's 8 on the side of Q2 and 8 on the side of, on the left side of Q2 and 8 on the side of, right side of Q2.
Okay, I
Right.
see what I did. I put Q2 into like a bracket and put the others on the outside of it instead of including the 75 and the 77 in those little areas.
Yeah, so 75 and 77 would be included in the
Right, so that just
yeah.
shifted everything.
Yeah, and it shifted it over. The last page, number 10, I try to kind of stress this in class, finding the rank and finding the percentile rank. So I told you the percentile rank was 65. Yeah. So you had to find N, and N is the number of people below Joe. Okay, so a lot of people found N as 7 or as 130 and said that was his rank, but that's the number of people below him. So his rank is going to be 200 minus 130, which is 70. 70 people are, he is the 70th person in the class. 130 people below him, his rank, his percentile rank is 65, which should have kind of been a little check. If you said his class rank was 130, you would know he would be below a 50% percentile rank. Because less than half the class would be below him if his percentile rank, or if his rank was 130, right? But his rank is 70, right? So he's better than half the class, at least. So that's 65 percentile rank. So a lot of people, again, I think that end up being 2 points or 3 points, depending on your work. 9 was meant to be a lot easier, and maybe the space threw a lot of people off. A lot easier than what you guys made it. So empirical rule kind of tells you it's going to be 1 standard deviation, 2 standard deviation, or 3 standard deviation. Turns out in this example, teachers with an income from $20 to $60,000, that puts them in the 2nd standard deviation. So 95% or 95.4%, depending on if you use the Z table or if you just memorize the empirical rule. So you would say 95% of the teachers would fall within that range using the data. Then part B was just saying, if I had 1,000 teachers, how many would fall within that range? 90%, or sorry, 95 or 95.4. So you could have 950 teachers or 954 teachers, and both of those were correct. So a lot of you guys made that a lot harder than it was meant to kind of be. And I don't know.
started to, like, I was doing a lot of
Yeah.
calculations, and then I just like.
Yeah,
wait a
some people
minute.
had some crazy stuff there.
Yeah, but then I went back and then down.
Again, the answer is just 950 teachers or 95%. It was an 8-point problem, so it was really kind of hard to gauge that, and that's why there was a curve at the end to kind of smooth that over.
I was concerned about the amount of space I had left, and I was like, I had to screw something out because there was a lot of
Yeah, and the reason why it ended up being that way is I have to kind of, space it out decently because I don't want like one problem on a page. So I actually made more space here than you really needed for that problem. Because I ended up having all this on one page and then I made it 2 pages because I wanted front and back.
Yeah.
Wanted to kind of use my space, and I think that caught some of you guys off guard. The last page, if you drew a picture, you got the right Z or got the right A values, you got some points. If you applied it correctly, then you got the right answer. So there was some partial credit there for 4 points on each problem. A lot of you got the right A value because you're just looking at a table for Z values, knowing what to do with it gave you the point. So drawing that, identifying them, take 0.5 minus my A values to get my answer there. Most of you got some partial credit here or all your credit. I think there's only, maybe a handful of people that got this problem fully correct. The number 11. So just to kind of go over number 11, just like the pretest, that if you made $1.75, how many people, what percent of the population makes less than $1.75? You had to convert the $1.70 or $7.51 to the Z value. You do the same thing with 60. You need to convert that to Z. And it turns out it's minus 2.64. Some of you guys did that, found the area, but then didn't know what to do with it. Take 0.5 minus that A value to get 0.004. I think 100 being 0, since the mean is 100, that corresponds to a Z value of 0. That confused a lot of people in the second part. Between 75 and 100 would correspond to between minus 1.67 and 0. So all you have to do is look at the table for Z equaling 1.67 and you get your A, you get your answer there. Because the setup, 100 is 0. So that's the definition of the on the area for the Z table, 0 to Z is the definition of A. So that meant to be pretty straightforward there. Again, difficult partial credit, either got all of it or none of it, and that's why I think the curve ended up being fair for the test. This will be posted to Blackboard so you guys can look at the answers, and there will be a blank test posted to Blackboard as well. So when we come to study for the final exam, you can pull up all blank exams and kind of study them. And the final exam will be composed of exam type questions. It's going to be worth 200 points. You'll have 2 hours, but it won't quite be double as long. I'm going to pull a couple questions from exam 1, a couple from exam 2, a couple from exam 3, and a couple from exam 4, and that will be your final.
Are you going to make it like extremely hard? Or
No. It's going to be.
optional, though, right? We're happy with our grades.
I'm not 100% sure on that. There's 2 other sections of Math 128, and other instructors teach it, and then there's some online sections. And so I haven't heard if it's coordinated or not. My other classes, they give me a final, say give this final, which means something. If I get my grades back, I can compare, the grades from section 1 to section 2, kind of compare how instructor did or the students did. But if they let me make up my own final, it doesn't mean anything comparing apples and oranges there. So I'm not for sure. I sent an email to our department chair and he hasn't got back to me yet. So as soon as I know for sure, I'll let you guys know.
About what?
If the final's optional.
The final's optional?
If the final's optional. I don't know yet. I'll keep you posted. For right now, it's
What
not.
does that mean?
Then if you like your grade, you don't have to take it.
I just want to point something out. So I think our final is on May 13th. Is that right?
The final exam for this course is in your syllabus.
Wednesday, May 13th, 11 a.m. to 2 p.m.
Okay.
Yeah, so
Okay, I've been like.
Okay, well, the 12th is my birthday. This will be really great because I'm turning 21.
it might be rough.
So it'd be really great if it was optional.
Okay, well, I'll see when I hear and then confirm with you guys.
If it is optional,
If,
Better drink some Gatorade.
yes.
Yeah, a lot of it.
can we decide to take it and then because it will still
Mhm.
replace the lowest grade,
Mhm.
right? And like, get the
If you
better of the
take
two
it-
options.
If you take it, it's gonna be graded and it's gonna be posted.
But what if
If I
we,
have to grade it, it's going in the grade book.
what if we tank it and like, okay, this
Yeah.
is gonna make me fail the class. I'm not gonna.
Yeah.
If you come here, you take it, I grade it, it goes in the grade book. So that's part of the battle. If it comes to be optional, it's part of the battle to know your strengths and know your weaknesses. But
But you said that if we do better on the final,
it will replace your lowest test grade. Yes,
But if you do
But it doesn't
worse
go
on
the other
final,
way.
You're screwed.
But it doesn't go the other way.
That makes
it doesn't go
sense.
the other way. So
Heck no.
that allows you to miss a test if something happens and we don't have a chance to make it up and you get to the final, it won't hurt your grade to replace it. That's why they have that policy. Okay, so we don't have too much time, but if we look at,
Oh, do you need this, by the way?
yes, I do, if you put your name on it, because right now it says you have a 0.
Okay.
So let's look at 10-1. 10-1 will probably go pretty fast, and I gave you a lot of a handout. There's a lot of words on that. What do I have? Yeah, 10-1 today. Okay. Bear with me here because this might be a review if you've ever taken a basic geometry class. Points, lines, planes, and angles. So we're getting into geometry. So we have to define what a point is, what a line is, what it means to be a plane, what it means to be an angle. So a lot of this is notation. Alternating interior angles, parallel lines, things like that are going to come up. We're going to define them, and then we're actually going to apply them later on. So our objective today is write a name for an angle. There's a couple different ways to do it. Define complementary and supplementary angles, and then solve problems like, this angle is supplementary to this angle, find the missing X value. So we use a little bit of algebra there. Use vertical angles to find angle measurements. We have to define a vertical angle and how that works. And then measure of angles formed by transversals. So we'll have parallel lines, they'll be cut by another line, and that's what's called a transversal. And then we'll be able to fill in missing angles. So starting out, the most basic geometric figure we study are points, lines, and planes. So geometry in the whole universe is defined on what a point, a line, and a plane is. A point is thought of as a location. So a lot of times we have coordinate systems, 0, 0, 0 for in 3 dimensions, or 0, 0 if we're in 2 dimensions. And a point would be how far away I am from the origin. So 3, 4. So I'm 3 units on the x-axis and 4 units on the y-axis away from the origin, right? If we get rid of the coordinate system, a point can exist anywhere in the universe, right? It can exist anywhere in space. So to give it meaning in geometry, we have to have some kind of coordinate system. It has no length, width, or thickness, so there's no dimensions to it. There's a really kind of fun video called Flatland. You guys heard of Flatland? It has to do with like this point who is just has no reference to what a line is because there's no width there. And then there's 2 dimensions, right? Which they're squares and circles and all these things, and they float around. They can't imagine 3 dimensions. And then it's just kind of, it's a fun little interactive video. But we think of everything in 3 dimensions, right? So for us to think of 4 dimensions is really difficult to think if there's another dimension out there. With points, we have, the next thing we have is a line, which is a set of points, connected points between 2 points. A line has infinite length. The line goes on forever. So these points can move anywhere on this line, right? They can go left and right. We'll assume that lines are straight, meaning that they follow the shortest path between any 2 points. So this being said, any line can be defined by 2 points on that line, right? So 1, 1, 2, 2. That line is a set of all points where x and y are the same. So I could define that by -5 to 5, 5. Or I could define that as 1, 1 to 2, 2. So we'll be talking about how to define a line. But a line goes on forever in both directions. A plane is where 2 lines intersect. It's 2-dimensional. It's a flat surface. It's infinite in length and width. It has no thickness. You might think of it like a piece of paper. So typically we think of the XY plane, right? This is the x-axis. This is the y-axis. But it can be tilted any way. This could be the XZ plane. Any way I can tilt this is a plane. The only thing I need to define a plane is 2 lines. Within, kind of like we think of a subset of a line, is a line segment. So a line segment is a point. It's a finite portion of a line consisting of 2 distinct points called endpoints. All the points on the line between them. We can have half lines. A lot of times in geometry, they're called rays. So if I take a point and I say everything to the left of that point goes on to infinity. And we'll see some examples of this. When the endpoint of a half line is included, we call that a ray. So here are some examples and figures and symbols. So I have a line. The line consists of AB. I would name that AB and I would put the symbol of the line on top of it. A line segment only includes point A, point B, and everything in between A and B. So it's kind of like I take this line and I cut it off. And I would write AB with a line with no arrows. A half line doesn't include the endpoint, but I could write it like this. A ray includes the endpoint and it's written like this. So some of these look very similar. And it's just a way to name a line segment, a half line, and a ray. We're really not going to do a lot with it as far as just naming it and being able to define. That's a ray, that's a line, that's a segment, that's a half line. An angle is formed by 2 rays. There's 3 ways you can name an angle. This angle, this should have the angle symbol. I don't know why it lost that when I upgraded to the new version of PowerPoint.
Ours have.
Oh, well, that's good. So you can name this as A, B, C, C, B, A, angle B, or angle 1. Various different ways to name it, right? If you have the 3 points, if you have an angle sign in front of it and 3 points, that's going to show you how to name the angle. Some programs, geometric programs, when you go to draw things, it's very important the order you do it in, clockwise or counterclockwise, what angle it's actually calculating. But we don't get into that because we don't do any kind of GeoGebra type programming in here. You can use a single letter as if there's no question. Here there's a question. If I said angle B, there's 3 different angles I could be talking about, right? I could be talking about this angle, or this angle. So you got to be a little careful here. Angle B is ambiguous because there's 3 different angles with the vertex of point B. So if I wanted ABC, that's different than CBD, which is different than BD. So first example, find 4 ways in which to name this angle. Pretty straightforward, right? I could call this angle 3. I could call it angle RST. I could call it angle S, or I could call it angle TSR. Right? Really, where this comes in important is later on, I'll give you a figure with a lot of angles on it and say, find the measurement of angle RST. So you know exactly what angle I'm talking about. Or angle 3. So measuring angles, one way to measure an angle is the degrees, symbolized by a little degree sign. 1 degree is defined as 1 divided by 360 of a complete rotation. There's other methods of finding angle measurements. There's radians, which we will not talk about in this class, but we'll focus on degrees here. So if we want to measure an angle, we want to find what it is in degree measurement. 1 degree is 1 divided by 360, and 360 is 1 full rotation. So we can use a protractor to measure angles of a degree. If I put a protractor here, this is 10, 20, 30, 40. And if I go all the way here, it becomes 20, 120, 130, 140, and so forth, right? So if I use a protractor, which we won't really be applying in this class, I can find this as a 40-degree angle. So the measure of angle ABC is 40 degrees. So there's 3 types of classification of angles. There's acute angles, which are between 0 and 90 degrees. There's a right angle, which is exactly 90 degrees. And anytime it's defined, it has to have a box in it if it's a right angle. Perpendicular lines will bisect at a right angle. So a lot of times they'll say, you know, this is the right angle. You know these 2 lines are perpendicular. And then the last is obtuse angle, and that is between 90 and 130. I mean 180. I don't know where I got 130 from. This is angle 3, 90 and 180 degrees. And then there's a straight angle, which is exactly 180 degrees. Straight angle is a straight line. Pairs of angles have various names depending on how they are related. So if they share a transversal, if they share a side, right, D, B, C, C, D, A, they share a common side. So we have some different a common vertex and a common side. These are called adjacent angles. So here, this is just the definition of adjacent angles. 1 and 2 are adjacent. Right? If 2 adjacent angles, if their sum add up to 90 degrees, the definition of that is complementary. Complementary angles sum to be 90 degrees. Right, so here's 2 examples. You know that GHJ is 90 degrees with the box there. So that tells you angle 1 plus angle 2 have to add up to 90 degrees. Right? That's called complementary. In the statement, it'll say angle 1 and angle 2 are complementary. Angle 1 is 20 degrees. Find angle 2's measurement. So you know 90 minus 20. There's supplementary angles. And that's got off here. Their sum is 180 degrees. Right? So if you know this is a straight line, and you have a ray coming off here, the angle sum from 1 to 2 is 180 degrees because they're supplementary. So here's some examples of solving for missing angles. If this angle is given as 28 degrees, what is this angle? right? 62 degrees, pretty straightforward. Eventually they'll put in some algebra, like this is 3x plus 2, and this is x. Then what would x be? So what are these angles? And we'll do some examples
So
of
it's
that.
just pretty much solving for x.
You're solving for x. You're setting it up. It's either going to equal 90 or it's going to equal 180, depending on if it's complementary or supplementary. Here's an example. Find the missing angle measurement. These are supplementary. So they might not tell you they're supplementary. I mean, they might not show you the picture where you can't tell if it's supplementary or complementary. They'll just give you the word supplementary or complementary. So it's important to know supplementary is 180 and complementary is 90. So this missing angle measurement is 45 degrees. Okay. So we know that they add up to be 180. So to find the missing one, I take 180 minus the one given, and I get 45. Here's a fun algebra type approach to this problem. Two adjacent angles are supplementary, and one angle is 3 times as large as the other. Find the measurement of each. Right, so if I was to kind of draw this, supplementary, so it's here. This is 3x, and this would be x, right? If I draw that. So how would I write an algebraic equation to solve for x? Yeah, 3x plus x equals 180. 4x equals 180. Oops. So what is x? 45 degrees. So the angles are 45 degrees and 135, right? So this is 135 degrees and this is 45 degrees. So it might give you kind of a word type problem and ask you to solve for a missing value. Pairs of angles. So we're going to get into a little bit more definitions here. Vertical angles are angles when I have 2 lines intersect. We have 4 angles that are formed. And vertical angles share a vertex. Okay, so 2 and 4 are vertical angles, and 1 and 3 are vertical angles, right? Turns out vertical angles are always equal. The reason why is because this is a line, so this is 180 degrees, and this is a line, so this is 180 degrees, right? So if 2, to find 1, you take 180 minus 2. To find 3, you take 180 minus the same angle 2. So 1 and 3 have to be congruent, which means the same. They have to equal each other. Vertical angles have the same measurement. Right? So looking at this example, we're given the measure of angle 1 is 40 degrees. Find the missing measurement. What is the measure of angle 3? 40, right? Because they're vertical. And in geometry, there's things called proofs, and you can use these theorems to prove that. So if you wanted to prove why is 3 30 degrees, you would say because they're vertical angles and vertical angles are congruent, right? What would be the angle measurement of 2? 140? And 4 would also be 140 because they're vertical angles. But another way to convince yourself angle 2 is 140 degrees is 180 minus 40, right? Here, this would also be 180 minus 40. So these are the equivalent, right? Vertical angles are congruent. Which leads us to transversal. So the first thing we have to define is parallel lines. So 2 lines are parallel, yet they never intersect. It's not really true because parallel lines intersect at infinity, but that's not really part of this class. But
I never heard that.
parallel lines intersect at infinity. But we define parallel lines, parallel 1 and 2 are parallel. If we bisect or intersect those parallel lines with another line, that's called a transversal. So here's an example of lines that are parallel that are cut by another line, and we end up with 8 angles. 1 and 4 are vertical angles, so they're congruent, right? 3 and 2 are vertical, so they're congruent, right? And it turns out we have this thing called alternating interior angles, which I'm going to prove in a minute. 1, 4, oops, use my wrong notation here, and 5 and 8 are the same angle measurement. And there's a theorem that says alternating interior angles are congruent. So 4 and 5 are alternating interior angles. How many of you heard of alternating interior angles before? So maybe more than half the class. So we have interior angles and exterior angles. And 3, 4, 5, and 6 are interior. 1, 2, 7, and 8 are exterior. Alternating interior angles. So 4 and 5 are alternating interior, and 3 and 6 are alternating interior. And that gives you that on your PowerPoint, right? Pairs of alternating interiors, and it turns out alternating interior angles are congruent, so their angle measurements are the same. Alternating exterior angles, turns out, have equal measurement. So alternating exterior angles have equal measurement, which makes sense because vertical angles are congruent, right? So these vertical angles are congruent. So if 5 and 4 are congruent because they're alternating interior, then 1 and 8 are congruent because they're alternating exterior. So some of this will come down to definitions. If I say, why are 1 and 8 congruent? You say because they're alternating exterior angles. Why are 4 and 5 congruent? Because they're alternating interior angles. Right? Corresponding angles are also congruent. So 1 corresponds to 5. If I was to pick up 1, 2, 3, 4 and put it on 5, 6, 7, 8, those would be the corresponding angles. So why are 1 and 5 congruent? Because they're corresponding angles. 2 and 6 are congruent because they're corresponding angles. Right?
So basically what you're saying is 2, 3, 6, and 7 are the same, and 5, 8, 1, and 4 are the same.
5 and 8 are the same because they're vertical angles.
Yeah.
1 and 4 are the same because they're vertical. 2 and 6 have the same angle measurement because they're corresponding.
And 3 and 7 have the same.
3 and 7 have the same because they're corresponding. 7 and 2 have the same because they're alternating exterior. So eventually I'm going to have you find the missing angle, but I'm also expecting you to be able to identify why they're congruent. How are they paired together? If I said 1 and 5, they're corresponding. If I said 1 and 8, they're alternating exterior. If I said 3 and 6, they're alternating interior, right? Alternating interior, alternating exterior, and corresponding are kind of different, or they're all congruent, right? And then the last thing, here's the corresponding angles. These are also on your handout that I gave you here. Here's an application. Angle measurement 2 is 50 degrees. Find the missing angle measurements.
130.
What would be 130?
1, 4, 5, and 8.
Yes, so this would be 130 degrees, 130 degrees, 130 degrees, and 130 degrees, right?
And all the rest.
And this would be 50, 50, and 50. Right? Alternating interior, alternating exterior, corresponding vertical angles. Right? You're using all those types there. This is pretty basic. We're going to get into geometry. We're going to get into a little bit more difficult figures where we have, maybe this is a triangle.
Oh.
And we're going to fill in angles there. But we're not quite there, so don't freak out on me yet. And these are filling them in. So this section, I know we kind of covered a lot today reviewing the test. It's pretty straightforward as far as, find the measure of 1 and 4, or what is 1 and 4 here? Alternating interior, alternating exterior, corresponding or vertical.
Alternating.
1 and 4
1 and 4
are vertical, right? 3 and 6,
Alternating interior.
alternating interior. 2 and 6,
Or no.
No, those are.
corresponding, right? So you guys kind of get the idea of just defining them. Eventually, we'll get into triangles, and then we're gonna merge alternating interior angles within triangles and knowing how to find the missing angle measurement there. And then again, there will be some algebra mixed in there, which is everyone's favorite approach to this type stuff.
How many sections are there now?
We cover, if you look at the syllabus, we're going to cover 1, 2, 3, 4, 5, and 6. Yeah. So 1, pretty basic. 2 is on triangles. You probably, some of the classifications like isosceles and obtuse, acute, equilateral, scalene, those types of definitions of what a triangle is. And we'll do like find the sides of a right triangle, like if you're given Pythagorean theorem, things like that. 10-4, 10-3, what is 10-3? Polygons and perimeter. So we'll get into if I need to fence in a garden, how much fence do I need? So if my garden is, we'll get into a little bit of area in the next section. So perimeter and polygons will define everyone's favorite, we have squares, rectangles, rhombus, parallelograms, decagons, hectagons, dodecagons, things like that, octagons, triangles, and we'll get into four-sided, which have a long classification, rhombus, square, rectangle, things like that. And then we'll go into like an octagon has so many sides, things like that, and angle measurements within that. Angle measurements of a square, angle measure of a parallelogram, classification like that. You guys have heard of that stuff before, right? Not the first time you're seeing it. And volume and surface area. So we'll talk about perimeter and we'll also talk about area and volume. So how much material do I need to make a can? How much material do I need to make a can that holds 12 liters? So we have volume and we have surface area and things that are related to that. If I want to paint a wall, surface area. If I want to fill up a container, that's volume. So we'll do some calculations and talk about what makes sense. If I'm talking about fencing in a garden, I need to know perimeter. I need to say, I need a garden that is 100 square feet. That's surface area. Right? I need a box that holds 30 feet cubed. I have so much surface area, I have so much volume, all these things are related. And so we won't go into too much detail about that, mostly just the formulas. So I might let you have a formula sheet for this next exam. And the reason why is because Mojia gives you a formula sheet. So what I ended up doing last semester is giving the same formula sheet Mojia did. So if you have to take Mojia, then this is the formulas you get from Mojia, this is the formulas I'll give you for the test. And then the last section we'll cover is right triangle geometry. You guys are so good. I've gone a minute over, so I'll let you go. But this is kind of a lot of students like this section because it comes to tricks, sine, cosine, tangent. See you guys on Monday. Enjoy your weekend.
It's sophomore year all over again.
Yeah. You guys will be ready for the ACT.
Yeah, right.